Hello TEP023 students, this is Helena and we are in week 4 of Foundation Mathematics, and in this week we are studying fraction operations, and we begin by looking at the addition and subtraction of fractions where the denominator remains the same. So we'll begin with a circle which has been divided into 12 equal parts. If we are given the fraction addition 5/12 plus 2/12, well, we can represent that diagrammatically by shading in red 5/12 of the circle, and then in blue 2/12 of the circle. How many twelfths of the circle are shaded in total? And the answer is 7/12. So what's happened? The denominator was the same in the two fractions we had to add. It remained the same and appears exactly the same in the answer. The only thing we needed to do was to add the two numerators. So the rules are up here. Leave the denominator as it is. Add or subtract the numerator as required. If necessary, give your answer as a mixed number. It's exactly the same with fraction subtraction. Our problem is 10/12 subtract 4/12. So it's taking me a little while to do it, but I'm shading 10/12 of this circle. Now if I wish to subtract from that shaded 10/12 4/12, let's see if I can do that easily. There's 1, there's 2, there's 3, there's 4. How many twelfths remain shaded? So the rule is the same. The denominator stays as it is and will be 12, and just perform the operation on the numerators. 10 minus 4 is 6, so we've got 6/12. Now with this one we can simplify the answer because 6 is a factor of 6 and 12, so we can divide 6 by 6 to get 1 and divide 12 by 6 to get an answer of 2. So half the circle is still shaded. As you can see, the equivalent fraction of a half out of 12 is 6 out of 12. So now let's look at some examples, and our examples are here. 7/15 plus 11/15. Well, we know that the denominator stays as it is, so it's 15, and we just need to operate on the two numerators. 7 plus 11 is 18. Now 18/15 is an improper fraction, so we need to change it to a mixed number. It'll become 1 and 3/15. But you should see that there's a common factor of 3 in that fraction, so we can cancel through or simplify the fraction, and 3 divides into 3 once, 3 divides into 15 5 times. So the answer is 1 and 1/5. Similarly, for the next one, we know that the denominator stays as 5. All we need to do is to operate on the numerators. So 17 take away 8 is 9/5. It's an improper fraction. Change it to a mixed number, 1 and 4/5, and we don't need to simplify that one any further. What happens if the denominator is different? So for instance, a half plus 1/12. Then we need to find the lowest common denominator, which is going to be a multiple of both the denominators, and we need to convert the fractions to denominators that are equivalent before the fraction operation can be carried out. So if we have a half plus a quarter, we can represent that as a half of the circle shaded plus a quarter. We know the answer is going to be 3/4. So how do we actually perform the problem? A half, I'll rewrite it, a half plus a quarter. The denominators are different. So we need to make 1/2 into an equivalent fraction out of 4. Now you need to include this as part of the problem. So you'll need to multiply by 2 out of 2 to make 1/2 into an equivalent fraction out of 4, plus 1/4. Don't forget that extra 1/4, that's the 1/4 that was here. Everything that is on one side of an equal sign must also be represented on the other side. So now we can multiply through here as we did before when we made equivalent fractions. And 1/2 as an equivalent fraction out of 4 is 2/4 plus that 1/4. Remember that the denominator stays as it is in the answer, and 2 plus 1 is 3. So the answer is 3/4, as we can see in our diagrammatic representation. We have 3/4 of the circle shaded. Actually, I've started the problem down here. Our next example is 5/7 plus 2/21. Again, we haven't got the same denominator in the two fractions we're adding, so we're going to have to turn 5/7 into an equivalent fraction out of 21. And so we'll have to multiply 5/7 by 3/3, because 7 times 3 will give us the equivalent fraction out of 21. Don't forget it's an equal sign, so everything that's on one side of the equal sign also is on the other side. Now we can multiply through. 5 times 3 is 15. 7 times 3 is 21. So we've got 15/21, add 2/21. Going down here. Notice all the working I'm doing. This is what I need to see when you perform one of these operations. The denominator stays as 21, so 15 plus 2 in the numerators. Add the two numbers in the numerator. 17/21 is the answer. The next one, I'll just make myself a little bit of room because it will be actually a biggish one, because we need to change the denominator on both of those fractions. So we're looking for the lowest common multiple of 4 and 5, which you should probably know by now is going to be 20. So how do we make 5 into 20? We have to multiply by 4. So 2/5 multiplied by 4/4 plus, no, it's not a plus, it's a minus this time, so minus 1/4. Now we want to make that into an equivalent fraction out of 20, so we're going to have to multiply by 5/5. So now we've got 2 times 4 is 8/20. Subtract 5/20. Now that the denominators are the same, we can perform the operation on the numerators. 8 subtract 5 equals 3/20. Notice the amount of working that has gone into solving this problem, and also notice that whatever has appeared on one side of the equal sign always turns up on the other side as well. The equal sign is a balancing sign. It's not an and sign. So you need to be very careful to make sure that whatever is on one side of an equal sign is also represented on the other side. This kind of working and setting out is extremely important in fraction operation questions, and you need to be able to demonstrate it when you complete your assignment questions. So the best way of doing that is to make sure that you show full working in all of your study guide exercises as you work through them.